Hi, grade 8. This is Miss Maricel Buerano, and today we will be talking about biconditional statements. Our goal for this lesson is for you to be able to write the conditional and converse of a general statement, find the truth values of each statement, and write the biconditional statement. I hope you will learn a lot. Before we proceed to our lesson, let us recall first our last week's lesson. So last time, we were able to write a conditional statement from a given general statement. So a conditional statement can be written in the form if P, then Q. And this is how we write it in symbols. If P, then Q. Then out of the conditional statement, we were able to write a converse statement. A converse statement is a statement that is formed by exchanging the hypothesis and the conclusion. So if Q, then P. In symbols, if Q, then P. So it's basically switching the hypothesis and the conclusion. And we were able also to write an inverse statement. An inverse statement is a statement that is formed by negating the hypothesis and the conclusion. So if not P, then not Q. And this is how we write it in symbol. If not P, then not Q. And the last is the contrapositive. The contrapositive is a statement that is formed by both exchanging and negating the hypothesis and the conclusion. So if not Q, then not P. In symbol, if not Q, then not P. Okay? Let's take a look at this example. We have here a general statement. A triangle with 3 equal sides is an equilateral triangle. Now let's form the 4 statements. So out of this general statement, we can have the conditional or the if-then statement. So we can form, if a triangle has 3 equal sides, then it is an equilateral triangle. So this is an if-then statement. So if P, then Q. Now, out of this conditional, we can write the converse. If Q, then P. So if a triangle is an equilateral, then it has 3 equal sides. And for the inverse, we negate the hypothesis and the conclusion. If not P, then not Q. So if a triangle does not have 3 equal sides, then it is not an equilateral triangle. And for contrapositive, if not Q, then not P. If a triangle is not an equilateral triangle, then it does not have 3 equal sides. I hope you will be able to remember that because it will be very helpful as we go to our next lesson. So what is a biconditional statement? A biconditional statement is a single true statement that combines a true conditional with its true converse. So it is a combination of 2 statements, the conditional statement and a converse statement. But before we can write a biconditional statement, 2 conditions must be met. First, the conditional statement should be true and the converse statement should also be true. A biconditional statement is written in the form P if and only if Q. This is how we write it in symbol. P if and only if Q. For example, 2 angles are supplementary if and only if the sum of their measures is 180 degrees. Again, I want to emphasize that before we can write a biconditional statement, it should meet 2 requirements. That's why it's a conditions. So two conditions. So if both the conditional statement and the converse statement are true, then we can write a biconditional statement. So we can write a biconditional statement if and only if the conditional statement and the converse statement are both true. Right, so out of our general statement, we have conditional statement. If a triangle has three equal sides, then it is an equilateral triangle. And for our converse, if a triangle is an equilateral triangle, then it has three equal sides. Now let us look at their truth values so that we will know if we can make a biconditional statement or not. So let's look at their truth value. If a triangle has three equal sides, then it is an equilateral triangle. Is it true or false? Yes, it's true. How about for our converse? If a triangle is an equilateral triangle, then it has three equal sides. True or false? That's right, it's also true. So we met the two requirements. Our conditional is true, our converse is true. Therefore, we can write a biconditional statement. So we will combine those two and we can say a triangle is an equilateral triangle if and only if it has three equal sides. Let's have another example. So our general statement is two angles with a sum of 180 degrees are supplementary angles. Let's form the conditional and the converse statement. So for the conditional, if the sum of two angles is 180 degrees, then they are supplementary. Let's check its truth value. Is it true that if the sum of two angles is 180 degrees, they are supplementary? Yes, it's true. How about for our converse statement? If two angles are supplementary, then the sum of their angles is 180 degrees. Is it true or false? If your answer is true, then you are correct. So, our conditional statement and converse statement, they are both true. It means that we can express them in a biconditional statement. So our statement will be, two angles are supplementary if and only if the sum of their measures is 180 degrees. Did you get that? Let's have another example. For our two statements, conditional and converse. For our conditional statement, if I live in Dongalo, then I live in Parañaque. Let's check its truth value. Is it true that if I live in Dongalo, then I live in Parañaque? Yes, it's true. Now let's check our second statement, the converse statement. If I live in Parañaque, then I live in Dongalo. Do you think it's always true? You're right, it's false. It might, yes, it's true that if I live in Parañaque, then I live in Dongalo, but I might also be in San Dionisio or in La Huerta, so it's not always true. And because we did not meet the two conditions, one is true, one is false, then we cannot make a biconditional statement. All right? Because by definition, it should be both the conditional and the converse. They should be true, right? And so in this case, The conditional is true and the converse is false. Therefore, it cannot be expressed in biconditional statement. All right, so that's how you scrutinize or you check whether you can make or you can express the two statements in a biconditional statement. Now it's your turn. Write the following definition in conditional statement, in converse statement, and in biconditional form. I will give you 3 minutes to answer this exercise. Please pause this video, and when you're done, play this video again. Let's check your answers. So for the conditional, if two angles are complementary, then the sum of their measures is 90 degrees. Did you get the same answer? Very good. So for the converse, if the sum of two angles is 90 degrees, then they are supplementary. All right, let's check their truth value. So in the conditional, if two angles are complementary, then the sum of their measure is 90 degrees. Is it true? Yes. So conditional, true. For the converse, if the sum of two angles is 90 degrees, then they are supplementary. True or false? That's right. It's also true. So conditional is true, converse is true. Therefore, we can write the biconditional. Two angles are complementary if and only if the sum of their angles is 90 degrees. Did you get that correctly? Good job. For our next exercise, you have to write the converse of the given conditional statement. If the converse is true, write the statement in a biconditional form. Let's check your answers. For converse, if an angle is acute, then the measure of its angle is less than 90 degrees. Let's check its truth value. Is it true that if an angle is acute, then the measure of its angle is less than 90 degrees? Yes, it's true. Therefore, we can write a biconditional. An angle is acute if and only if the measure of its angle is less than 90 degrees. Did you get that right? Very good.